We are solving the two sum problem, which is a classic coding interview problem on LeetCode. So let's start the problem first and then we'll jump into the solution. So given an array, an integer of numbers and integer of target, return indices of the two numbers such that they add up to a target. And you may assume that each input would have exactly one solution and you may not use the same element twice. So you can return the answer in any order. So this is the question. And for example, you can say we have a array of numbers which is 2, 7, 11 and 15. So this is the numbers and target is 9. So we need to find the pair of the numbers which sums up to 9. So 2 plus 7 is 9. So you can say because numbers 0 plus number 1 is equals to 9, which means the indices of 2 is 0 and indices of 7 is 1. So it return 0 of 1. Similarly, in example 2, if you will see, it has 3, 2, 4 and target is 6. So we need to find the indices whose value sum is equals to 6. So 2 plus 4 is equals to 6. So indices of 2 is 1 and indices of 4 is 2. So we need to return 1 comma 2. And for example 3, 3 comma 3 and target is 6. So 0 comma 1. So indices of 3 is first 3 is 0 and indices of second 3 is 1. So this is the example. So I hope you understand the question, and there is also one thing follow up. Can you come up with an algorithm that is less than order of n square in time complexity, or bigger of n square in time complexity? So we will cover this. Okay, so let's start. I hope we understand the problem. So let's start with a simple brute force approach, and then we optimize it. So first we will solve in brute force approach. So first let's look at the simplest solution, which is brute force. And what we will use is we will use two loops and check every pair. If their sum equals to the target, then we return the indices. So let's write the code. So for let me explain it. For I in range of length of nums. So this is the first loop which will give us the first element, and then the second loop for j in range of I plus 1, which is the first element, comma length of nums. So this will give us the second element, and what we need to check here is if nums of I, that is the first element, plus nums of j, which is the second element, is equals to target. It means we find the number 1 and number 2. So the indices of number 1 is I and number of indices of number 2 is j. So what we need to return the indices, which means we can return I comma j, which will return the indices. Okay, and if nothing is found, then we will return the empty indices. So this is the our brute force, and the complexity of this program is order of n squared. So if you will see, the time complexity of this program is order of n square. So this is the time complexity. So let's run this program and see the solution. So it has three test cases: case 1, case 2 and case 3, and all are accepted. So we have a working solution. So let me comment it for now, not the definition. We'll just comment out the solution part, and this is a solution box, but it is slow. Time complexity is also big of n square because of two nested loops is there. So it is not efficient for large arrays. So now let's optimize it using a hash map. So we will optimize this using a hash map approach. So now let's use a hash map for a faster solution. And the approach will be we iterate through the array only once and store number in their indices into a dictionary. If we find that complement, which is target minus number, we return that indices. So let's write the optimized code. So we already have a solution here. So first of all, we need to define the mapping, which is the hash map, and then so this will store what it store is it's a dictionary. It's a dictionary to store number and index. So number and then index. Okay. So let's say for I comma number in enumerate, this will give us the value and the index both in the enumerate will give. Okay. So we have nums in that, and then we will find the complement, which is target minus number, which will give us the complement, which is the needed number. This is the number which we need, right? Target minus number equals to complement, and this is the number which we are looking for. So if complement in our hash map in mapping, then we will return the number hash map of number, which will give us the indices, and not the number, the complement, the hash number map complement, hash map of complement, which will give us the indices of this complement value, and then the I, which will return the indices, return indices. Okay. And then if it is not in the hash map, then what we'll do is we will insert that number into the that index. So we will insert that number like this number on the index. So we are storing into the map if it is not available, and in the next loop again it will check, and if found then it will return the indices, and if loops ended and nothing found, then it will return the blank array. So this is the solution, which is much faster, and time complexity is also order of n. Time complexity, if we will talk about, then time complexity is big of n. So this solution is much faster,